Okay, so far we talked about functional dependency. That is the most important concept you need to understand to do normalization. So now we are ready to do normalize real data. So we are going to use the same example, the report of the company that are dealing with many projects. So in this report layout, first, we have to convert this report into kind of a tabular form because that is a starting point of the database design. So we are going to copy everything into one big table. But just one thing you need to note is we mentioned before in conceptual modeling as well, but there are some derived value, total charges. This total charge is the multiplication of two numbers, charge hour and hours billed. So the problem, if you save this derived value in the table, later when you update, for example, charge hour or hours billed, you need to manually update the total charges as well. So then sometimes if you forget to update this derived value, and it can cause kind of serious problems in the future. The bottom line here is if there is any derived value, you don't need to save it in the database. So except this total charge, if you copy everything into a tabular representation like this, you may have the same information. Let's say we read this highlighted line, the third line, then definitely this is the information about Evergreen project and one of the employee who is working for this project, that is Alice. So we can understand what is this employee's job class, charge hour, and hours. However, when just look at this one specific row, although we know that this is part of Evergreen project, this line itself does not have the information whether it's Evergreen project. So if you want to use one specific line by itself, you have to fill in this missing cell like 15 and the Evergreen. So in this report, we have some repeating groups based on the project, and there is a horizontal line, and we know that everything here is part of that project. But when you use a database, since we may read each line separately, if there is information about project number and the project name, although it's gonna be the same information, we have to fill in those missing cells and we have to make a complete data set for each line. Then as a result, what you will get here is this complete table. So this complete table do not have any missing values, particularly here you can see it's all filled in, 15 Evergreen, and here we have project 18 Amber Wave. So now in this complete table form, when you read each line, you can get all the information about that specific line, which project and who is working for that project, and the relevant job information as well. So when you have this complete table, we say that we just eliminated repeating group. Elimination of repeating group means instead of grouping, we have a complete data set. We can say that we already have a first normal form. Now, using this first normal form, you need to further develop the second normal form. So when we develop second normal form, there are some steps you need to follow. So look at your class notes, and I will follow the same step given in your class notes. Using this first normal form, now we can further develop the second normal form. In this first normal form, since we have a complete data set, so you have to now start to think about primary key of this table. What will be the primary key? Primary key means the key that can uniquely identify each instance. Instance means each row. So if, for example, if we use just the project number, can we uniquely identify one specific row here? No. Why? Because we have several rows with the same numbers, 15. That makes sense because in one project there are many employees assigned, so we have several rows with the same project number. Then how can I uniquely identify just one specific row like this? In addition to project number, actually you need to specify who is working. So to pick one employee, the best way you can pick one employee is using employee number. And what with the primary key, it's not just one attribute, but it is combination of two attributes, that is project number and employee number. So we are going to identify primary key as project number plus employee number. Since we have more than two attributes or columns, we call this, by the way, composite primary key. So composite primary key. After you found the primary key, now we need to identify all dependencies. First, based on the primary key identified, we know that primary key determines one instance. Therefore, in other words, primary key combination can determine all other attributes. So here, the first one is based on primary key that we found. On the left side, we can put project number and the employee number together. And on the right side, we can determine everything else. Project name and employee name and job class and charge hour and lastly hours. So all other attributes are determined by this primary key, because if I give you one number, one attribute, for example 15, and if I give you 101, you can always determine, let's see where it is, 15 and 101, you will pick just one row. So definitely for other attributes, you can determine only one values here. So we can say that there is a functional dependency. In addition to this primary key based functional dependency, we can find that if there is a project number by itself, we can determine some attributes on the right side. Even without employee number, you may easily find that project name can be determined. So let's write down that one. Okay, so project number itself, it will determine project name alone. And one more here, employee number itself. So let me use different colors here. Employee number can determine employee name, and also given one employee, we can determine job class, and given job class, actually we can determine charge hour as well. But note that hours we cannot determine just by employee number, because the same employee can work for different projects. So note that hours we cannot determine using employee number. So let's write down here, employee number, this is a part of a primary key, can determine employee name and the job class and the charge hour. So using each component of the composite primary key, we can find those two additional dependencies. Lastly, you can find another kind of hidden dependencies that I mentioned already. So employee number determine job class, and also employee number determine charge hour. But as I mentioned before, because this of hidden job class to charge hour dependence, actually we could determine this from employee number to charge hour. Therefore, the connecting part is job class to charge hour. We name this as a transitive dependency. In addition to these two dependencies, we have one more dependency here, and that is job class to charge hour. So this is the list of all the functional dependencies. in summary, what we found here is, first of all, based on the primary key, we found the functional dependency given here. When you have a composite primary key like this, try to evaluate whether each of this primary key attribute can determine some other attributes. So we found that one attribute, project number, can determine project name, and the other attribute, employee number, can determine employee name, job class, and charge hour. These two dependencies found here is the determinant is part of primary key, so we call them partial dependencies. But here, given hours, it is still determined by both the project number and the employee number. Dependency from project number plus employee number to hours, this is called actually full functional dependencies. Lastly, we found the connecting dependency from job class to charge hour. So found here, this is called transitive dependency. One more time, let me summarize what we have found using the first normal form. In the first normal form, there is one big table, and in one big table, we have several columns given here. And the first job you need to do is finding primary key. So what we found, project number and the employee number. So underline this project number and the employee number, and from primary key, so this composite primary key, you can see it determine everything else. So the first functional dependency on top is based on the primary key. Since primary key is composite primary key, there could be partial dependencies, so we need to evaluate. So let's just pick project number, the first column. Then what we found, there is a dependency to project name, and we name it as what? Partial dependency. And the other one is employee number, so we evaluate employee number can determine employee name, job class, and the charge hour. And note that hours, you cannot determine just one of primary key attribute, but you need both of them. So the dependency to hour is called the full functional dependency, but for all others, we can see partial dependency. And one more thing, there is a kind of connecting, bridging dependency from job class to charge hour. It is called the transitive dependency. So if you use this kind of diagram, it is called the functional dependency diagram. So this very efficient way to show all the functional dependencies in a given one table. And another way you can represent this is using this kind of parenthesis and the list of attributes. It's called the relational schema. Relational schema. So each parenthesis means one table. Right now we have just one table. Later we are going to divide it into several tables, but just one table is given. And the current level of normalization is the first normal form. And you list up all those attributes and underline the primary key. And from here, again, we have a partial dependency, two partial dependency, and I'm showing one transitive dependency. So when you do your assignment, you may need to draw this kind of functional dependency diagram. Now, based on this, our next step is we need to make a second normal form. In general, if you found the partial dependencies or transitive dependencies, they are bad signs. That means this implies we have some redundancies or anomalies. So basically, we need to remove all the partial dependencies and the transitive dependencies while we are normalizing the data. So the first focus is given to partial dependencies. If you remove partial dependency, which means you will obtain second normal form. So let's see how we can remove partial dependencies. Okay, so let's start to make a second normal form. Here on the right side, I'm showing you the first normal form one more time as a reference. So based on the result of this first normal form, we are going to remove those partial dependencies. The way you can do is given here. First, write each key component. Each key component means since we have a composite primary key, one is project number and the other one is employee number. So let's write down this and also list both of them, project number and the employee number together. So the last line is original composite key. And using these three bullet points or three attributes and the combination of those attributes, we are going to make a new table, new relational schema. Schema means just a table. So how to make a new table? A name is already given, but usually before you name it, you will list tables. How to make a table inside the parentheses. So in this parenthesis, first using project number, I will write down project number here. And then using this partial dependency given here on top, list all the attributes. In the first partial dependency, we have a project number plus project name. And I underline here in project number because project number will be used as the key of this new relational schema or new table. And we name it as project because project number is primary key and project name is the other attribute, and it makes sense. What would be the good name? You may just pick project as a name. And the next partial dependence given here is from employee number. So employee number, this would be our new key value. So I will underline it. And what other attributes you have to include given in partial dependency? So employee name and the job class and the charge hour. Note that still we have transitive dependency here, but we do not worry about, you don't have to worry about this transitive dependency in this step, second normal form. And lastly, assignment. In assignment, we are going to put both original composite primary key. So let's say project number and the employee number together. It makes a primary key. And then what other attributes actually you need to include here? Since project name is already in this new table, employee name, job class, charge hour is in the second new table. So what's left? There are only hours left. All other attributes are already moved to a new table. So here you need to write down only hours. So basically, assignment, you will find what? Full functional dependency. And all partial dependencies will create new tables. So removing partial dependencies means creating new tables with those partial dependencies. So as a result, if I use a similar format, like a functional dependency diagram, we will get this. Now we have how many tables? 3 tables. The first table is project. Second table is employee. How did we make it? Breaking the partial dependencies. And the original composite primary key create assigned hours. Actually, hours are same as assigned hours. So assigned hours, and we still keep it because it's a full functional dependency. And note that when we look at functional dependency, we have to evaluate each table. So in this new tables, let's try to evaluate functional dependency one more time. So while we are evaluating functional dependency in this project table, do not look at other tables, just look at one table. First of all, in this new table, do we have a composite primary key? No, we do not have a composite primary key because project number is just a single attribute primary key. Therefore, can we think about partial dependency? No. Why? Because it is not composite primary key. So definitely there is no partial dependency. And is there any transitive dependency? No. So this project tables, only this project table, do not look at other tables. This project table, if there is no partial dependency, and it does not have transitive dependency either, then you can say that it's not only second normal form, it's already what? Third normal form. Why? Because there is no transitive dependency. Let's look at the second one. If you look at this new table, employee table, again, the primary key is employee number. Since we have only employee number as a primary key, there is no partial dependency. So we know that it's already second normal form. Now, if you look at this table, can you find any transitive dependency? Yes, still there is a transitive dependency given here. So for this employee new tables, we know that it is a second normal form, but is it third normal form? No. Why? Because there is a still transitive dependency. So you can say that it's a second normal form, but you cannot say it's a third normal form yet. Lastly, let's look at this assignment tables. So for this assignment table, you can see that project number and employee numbers are composite primary key. So since it's a composite primary key, you may think about partial dependency. However, is there any attribute you can determine with the project number? No. Why? Because it's already moved to this new table. So there is nothing you can determine with the project number by itself. How about employee number? No. So there is no partial dependency when we look at just assignment tables. Again, when you evaluate the functional dependency, note that you have to look at each table separately. Now we are looking at assignment table. Although we have a composite primary key, there is no partial dependency. Our is determined by only when we use both of them. So this is a full functional dependency and it's not partial dependency. So when we look at assignment table, there is no partial dependency. And at the same time, if you try to find the transitive dependency, you cannot find any transitive dependency here in this table. So there is no partial dependency, no transitive dependency, therefore it's already third normal form. So in these three tables, only one table we need to further normalize. Which one? That is the second employee table, because it has a transitive dependency here. So we need to remove this transitive dependency in the following step. But since project table and the assignment table, these two tables are already third normal form, there's nothing we need to do. Okay, now how to make a third normal form? We will just focus on the previous employee table. And in that employee table, we found the transitive dependency, that is a job class to charge hour. So to remove this transitive dependency, first we need to identify the new determinant, that is a job class. And similar to partial dependencies, given this transitive dependency job class to charge hour, we are going to make new tables. New table using relational schema here. Job class, the determinant of this transitive dependency would be what? Primary key. So we underlined here. And the other attributes, so dependent attributes, will be the attribute of this new table. So if you look at this job class and the charge hour together as a table, what would be the good name? Job would be the good name. So we make this job as the new table. Now, the original employee table, actually what we need to do is, since we created a new table, we have to remove some attributes from the original tables. So if you look at the original table in the second normal form, you may remember here employee, and what we have originally, employee number and the employee name, and the job class, and the charge hour. So when we created this job table, job class and the charge hour, these two and the employee name is primary key, by the way, is moved to this new table. So sometimes students are tempted to remove both of these attributes, but just be careful. In this case, when you create a new table with transitive dependency, the charge hour would be removed, but you need to keep the original determinant. So in this case, job class would be still there in this employee table, and you should not remove this job class, although job class is shown here as the primary key as well, but you have to keep it in original employee table as well. So as a conclusion, in the third normal form, how many tables now we have? This project table, it's the same as the previous step, and this assignment table is also same, but now employee table in the second normal form was further normalized. We have this new table, job table, so charge hour is given here, and job class, the determinant of a transitive dependency is used as the primary key, and we name it as a job. So now we have 4 tables. Again, if you need to evaluate functional dependence, you have to do it for each table, right? So as a conclusion, let's do it one more time. So in this project table, what is the primary key? Project number. It's not composite primary key, so there is no partial dependency. So it's a second normal form, and there is no transitive dependency either. So we say it's a third normal form. Now, assignment first. We have composite primary key, but there is no partial dependence because ours is determined by both of employee number and the project number. So with this full functional dependency and no partial dependency is already second normal form, and there is no transitive dependency, so therefore it is also third normal form. Previously with the charge hour, we have a transitive dependency. So employee table was second normal form, but it was not third normal form. But now we removed this charge hour. Therefore, there is no partial dependency, and at the same time, there is no transitive dependency. So we can say that it's also third normal form. Now this new table, job class and charge hour, definitely the primary key is just a single attribute primary key, and there is no partial dependency. And there is no transitive dependency either. So everything is third normal form. So when you normalize, you will get more tables since you are removing redundancies by making more tables. It's very similar to ER diagrams with several entities, but they are related together. So as a result, we have this third normal form with 4 tables, and there is no partial dependency, and there is no transitive dependency.